Hello everyone. In this video, we're going to be solving an interesting problem with functions. And this problem is kind of, I think, homemade because I thought about the idea, but my inspiration was another problem that I've done a while ago on this channel. And hopefully you were able to check my other channel, which is aplusbi, which focuses on complex numbers. Oops, I can't even spell A plus bi. Okay, that's what the channel looks like, and let me know what you think. So we have this interesting function, f of x equals x squared. And now we're supposed to find f of 1. Can we find it with this information? Of course, certain conditions can change the nature of this function. But for now, I'm just going to do free flow. It can be pretty much anything. But how do you find f of 1 from f of x? And obviously, that kind of makes sense to replace x with 1, doesn't it? Even though it's not going to give you f of 1 directly, it'll give you f of 1 indirectly. Maybe. Who knows, right? But before we get into that, I want to tell you something else, which is interesting. Can we actually find what f of x is or what it looks like before we find f of 1? Because that would be awesome, don't you think? We can pretty much find anything after that. So is there a function that satisfies this? And what happens if there's no function that satisfies it and you can still solve for f of 1? That happened actually in the other problem. I also shared a link to an article which is pretty interesting. You're probably wondering what that problem is going to look like, right? I'm going to show you what that problem is. I'll share the links down below so you can also check that problem out, because I think it's a really, really nice problem, and I don't know how they came up with the idea. I tried to modify that problem like by making some changes and try to come up with a similar problem. I couldn't do it. Maybe if you can, let me know, because that's a really interesting problem. Anyways, I think this one is also interesting because it's going to be similar. Okay, ready? Okay, now we have f of x, and I already told you that we could replace x with 1, but that's not what I want to do first. I want to find f of x. So here's my question to you. Think about this. If f of x is equal to x squared, what could f of x be? Can you think of a function that would satisfy this? For example, can f of x be a linear function like x? Well, if f of x is x, then f of x is also x because you replace x with x. Okay, can f of x be x squared? Well, if f of x is x squared, then f of x is just going to be f of x squared. But f just takes the input and squares it, so it's going to be x squared squared, which is x to the 4th power. So if f of x is x squared, f of x would be x to the 4th power. Uh-oh, it didn't work because we got a quartic. That makes me think. We got a quartic from a quadratic. So we squared the power, right? 2 times 2 equals 4. So how do you reverse that? Try to reverse engineer that process. Usually that's how we can work with functions, like kind of working backwards. What should f of x look like so that when I compose it with itself, I get x squared? And the answer is you have to think a number whose square equals 2. And there are 2 such numbers, root 2 and negative root 2, right? So then, is it possible for f of x to look like this? Uh-oh, we almost made a breakthrough, didn't we? Because we guessed for f of x, but we didn't check yet. It's a method, as you know, a problem-solving strategy, guess and check. Let's go ahead and do the second part. We have to check to make sure this works. How do we check that? We're going to find f of x, but f of x is x to the power root 2. F of something is something to the power root 2. So this is going to be x to the power root 2 to the power root 2, which is x to the power root 2 times root 2, which is x to the power 2. Uh-oh. Houston, we have a solution. Beautiful, right? So if f of x is this, then f of x would be x squared. Of course, f needs to be continuous, right? Does it? Anyways, is it differentiable as well? Those are good questions. I want you to look into those. But notice that from a non-rigor perspective, this seems to be working. What about the other square root? You know, there are 2 numbers whose square equals 2, right? What about f of x equals x to the power negative root 2? Is that going to work? Let's test it out. F of x is f of x to the power negative root 2, which means take the input and raise it to the power negative root 2, which means x to the second power. Again, because their product is 2, it works. See, we got 2 solutions so far. Isn't that beautiful? And you don't really need a bunch of other solutions, because what you can do is use these, can we? Let's go ahead and use it. And what's interesting about this problem is that when I present the second method, you're going to see something different. And I want you to compare the first and second method and see how they compare and contrast. And why do we have a discrepancy? What discrepancy am I talking about? I'm going to tell you a little later. When we do the second method, you're going to see that there seems to be something different about the second method, okay? But we were able to find f of x, so we're happy. Let's go ahead and now find f of 1 here, which would be the easiest thing. How do you find f of 1? You just replace x with 1, and that gives you 1. What do you get with the second one? Same thing. So consistently, we got f of 1 equals 1. So that seems to be the answer for now. Why do I say that? You'll see in a little bit. So hang in there, stay tuned, because we're about to start the second method. All right? So here's the second method. Instead of trying to guess what f of x is, because what would happen if f of x was something like this, right? Would you be able to guess f of x? Probably not. I don't think there's a solution for this. There may be, I don't know. But again, the other problem is pretty interesting. Please look into that and let me know what you think, because that's a really interesting problem. The other video I'm talking about. So let's think about it this way. Instead of trying to guess what f of x is, let's try to find f of 1 only, because you don't really need to find. They're not asking for f of x, are they? So why would you do extra work, right? So kind of being lazy helps here. So let's replace x with 1. That gives us f of 1 equals 1 squared, which is 1. Beautiful, right? Now we found that f of 1 is equal to 1. We don't know what f of 1 is. What the heck is f of 1, right? Okay, don't worry about it. Let's just call it a, because it's a constant, isn't it? 1 is a number, a numerical value, and when you plug it in, you'll get a numerical value, which is a constant. Great. So a is a constant, even though we use a letter to represent it. And now, what does that mean, though? Well, we were looking for f of 1, and f of 1 is equal to a. Is that the answer? Well, we have to find what a is. Now, here's the fun part. To get some idea about this, because this gives us 2 things. First of all, we made an assumption, okay? We said that, okay, not an assumption, kind of like a renaming. We set f of 1 equal to a. Yes, okay, fine. But notice, from here you got something else. Take a good look. Look at the big picture. This also gives you f of a equals 1. That's kind of like a cyclical relationship, isn't it? F of 1 equals a, f of a equals 1. F of 1 equals a, f of a equals 1. So you can kind of do like f of, you know, that's going to go on forever. But that's an interesting scenario, don't you think? Now, we're going to use these 2 pieces of information, because I think that's kind of like a system, don't you think? What is the next thing we should do? Well, it makes a lot of sense to replace x with a. Why? Because we want to have, like, we want to get an idea about f of a. What is that going to look like? When you replace x with a here, of course, right? That's going to give you f of a equals a squared. Great. But is this helpful at all? Yes, because you know what f of a is. What is f of a? It's equal to 1. Ta-da-da-da. Replace f of a with 1, and you get f of 1 equals a squared. Great. Is this helpful? Because I was trying to find f of 1, but a squared is unknown. Well, f of 1 is also equal to a. If 2 things are equal to the same thing, then they're equal. What is that supposed to mean? Look, f of 1 is a squared, f of 1 is a, so a squared equals a. Great, right? If a squared is equal to a, don't just cancel out a's, factor out like this, subtract a, of course, first, and then from here you get a equals 0 or a equals 1. But wait a minute, what is a? A is f of 1. And we were trying to find that. So this means f of 1 is 0. This means f of 1 is 1. Going back to the first method. Now remember, we found that f of 1 is 1 only. Why is it the case that we were able to find a different value here? Where does the discrepancy come from? That's for you to find out. Let me know what you think, because this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and don't forget to check out SyberMath and aplusbi, and bye-bye.